For number 2, you just needed to rehash what the table said on page 234. So you needed to mention that there were a fixed number of trials. The trials are independent. Each trial has only 2 outcomes. And then that the success of the same is consistent trial after trial. That's what makes a binomial, that's what makes an experiment a binomial experiment. And then what does the random variable of the binomial experiment measure? That's what is R? And R is measuring the success, the number of successes out of our n trials. So if we ran the experiment 30 times, R could be any number 0 through 30, because there could be either 0 successes, 1 success, 2 success, all the way up to 30. So R is measuring the number of successes. As the number of trials increases, the expected value and the standard deviation will both increase as well. And you needed to explain why. So if you think about the expected value, as you're running more trials, there are more opportunities for success. So the expected value should increase. The number of successes that you expect should increase. And you can also see it directly from the formula. As the number of trials increases, that means n's getting bigger. So you're multiplying by a larger number, which will make the expected value, the mean, increase. And as the number of trials increases, the standard deviation increases. There's more options now for outcomes. The data is going to be more spread out. The standard deviation is going to be bigger. You can also see it directly from the formula. Again, you're multiplying by n, so as n gets bigger, this number underneath the square root is going to get bigger, which makes the entire calculation bigger. The standard deviation increases. So we're going to use binomial probability to answer this. For A, there are n is 20 because we're selecting 20 pins. The probability of success of getting a pin that's bad is 5%. And what is our R? What are the number of successes we're looking for? Well, we're either looking for 0 successes, 1 success, or 2 success. So we're looking for either 0, 1, or 2 bad pins, because as long as there's no more than 2 bad pins, we're going to accept the shipment. So let's figure out the probability of either 0, 1, or 2 bad pins if 5% of the pins are defective. So as you did the Excel for this week, you learned about how to do binomial distributions in Excel. So for this problem, we're looking for 2 or less successes out of the 20 trials, the 20 pins we're sampling, and there's a 5% chance of success. And in this case, success is getting a bad pin. So we're looking for 2 or less of those. That's why we put true here. When you put true, it does the accumulation of 2 all the way down to 0. So 2, 1, or 0. So let me put an equal sign in front of that, and it'll calculate. There is a 92.452% chance that when we look at those 20 pins, we're going to get 2 or less defective. So that means there's a 92% chance we will accept the shipment of pins. Part B, some things have switched up here. Now we want the probability the shipment is not accepted, and there's 15% of the total pins that are bad. So let's go back into Excel. So again, we're looking at 20 pins, 15% chance that the pin's defective. So let's first start and just figure out the probability that we will accept the shipment, which means there's either 2 or less defective pins. So we use true again and put an equal sign in front of that. Let me copy that first. Copy. Okay. So there is a 40.49% chance we're going to accept the shipment because we'll only get 0, 1, or 2 pins that are defective. When we test 20 of them, we'll only find 0, 1, or 2 that are defective. But the problem wants to know what's the probability we do not accept the shipment. So if there's this is the probability that we do accept it, then 1 minus that should be the probability that we don't accept it. So I have 1 minus what I got there for A5. There is a 59.51% chance that we will reject the entire shipment of pins, because when we sample 20, it's going to be the case that we get more than 2 defective pins. Maybe we found 3, maybe we found 4, maybe we found 15 or 16, who knows, but 59% of the time we'll find more than 2 defective, so we'll reject the shipment 59% of the time. And so you see up here we accepted it 92% because there was only 5% bad, but when it went to 15% bad pins, it was only 40% acceptance. So it's more likely to get rejected because the number of bad pins increased 3 times as much.